Alright, welcome to the very first video for 2.2. There's going to be 3 videos on 2.2, so this is day 1. We're going to be working on end behavior of graphs. And basically what we're going to do is we're going to start looking at graphs where the degree, or which is also known as the highest exponent for each, is going to be a lot bigger than the ones we work with. You know, it's going to be 4 or 5 or 6 or 7. And we're going to see a connection with the degree, and at least today with the end behavior of the graphs. Now, I'm first going to look at these 4, and we really know what these general shapes are. And I'm just going to graph the whole thing, and then we're going to talk about end behavior. Basically what this means is what happens to the graph when you go to the left. Does it go up or down? What happens to the graph when you go all the way to the right? Does it go up or does it go down? Well, if we get our first one, y equals x, well, we know that's just a line that goes up left to right. So we could say this is the end behavior. To the left it goes down, to the right it goes up. Okay, and then when we look at y equals x squared, well, that's our basic parabola. I'm just going to put the parabola. Right? Both ways, to the left it goes up, and to the right it goes up. Well, y equals x cubed, this is our S shape. Now, this is like the first one. This is like the line. To the left it goes down, to the right it goes up. If you graph y equals x to the 4th, it's really going to be the same exact type of graph as number 2. It's going to be a parabola, except it's going to get skinnier, it's going to get narrower. But it has the same end behavior. It goes up left, and it goes up to the right. So right away, you can see the connections with number 2 and 4, where those degrees are even. What I mean by degree is the highest exponent there, 2, highest exponent here, 4, they're even. Okay, let's just kind of summarize this. And when we look at this and we summarize it, we basically just did this right here where the leading coefficient is positive, meaning that this is y equals 1x squared, this is y equals 1x cubed, this is y equals 1x to the 4th. We know if we change it to a negative, everything's going to flip. All right, the degree is even, so we're working with these two cases, number 2 and number 4. If the degree is even, and the leading coefficient is positive, like in these two cases for 2 and 4, then this is what we say. They both go up. All right, that's all I'm going to put. I'm going to put 2 arrows, one to the left and one to the right. I'm not going to worry about the middle portion of the graph. I'm going to worry about that later in the next couple videos. Now this part I didn't look at, leading coefficient's negative. Well, if I took this and made this negative x squared, well, I know this flips. So now they both go down. Same thing with this. If I put negative x to the 4th, the parabola just flips, they both go down. So it's pretty easy when it's even, they either both go up or they both go down. All right, I know that right away with the graph without even making an XY chart, without doing anything else, without graphing it on my graphing calculator. I know how the graph behaves when you go all the way to the left and when you go all the way to the right. All right, when we look at our degree as odd, so this is when it's number 1 and number 3, this is where they go opposite directions. Now, if your leading coefficient is positive, like here it's y equals 1x, and this is y equals 1x cubed, they go up left to right, so they go down to the left, and they go up to the right. So let's fill this in the chart. So if the degree is odd, we can say this just looks like the normal S-curve or a normal line that goes up left to right. So I'm going to put this. It goes, when it goes to the left, it goes down. When it goes all the way to the right, it goes up. So it's increasing. If it's negative, it flips. It looks like this. To the left it goes up, and to the right it goes down. You know, here's an example right here. If we graphed negative x cubed, well, this is what it would look like. The S-curve would go down left to right. So to the left it goes up, to the right it goes down. That's what we have right there. All right, so not a whole lot of thinking going on. There's really 2 things you need to think of. All right, is the degree even or is it odd? I know if it's even, they either both go up or they both go down. If the degree is odd, one's up, one's down. And to know which one it is, we just look at the leading coefficient. All right, last thing, let's just look at some equations. And we're going to get the answers right away. And all we're going to do is just draw arrows. I'm not going to graph the whole thing. Don't waste your time putting this on the TI Nspire. Let's just use common sense right here and use what we just learned. All right, the first one there. We have y equals x to the 4th minus 3x. The degree here, or the highest exponent, is 4. So they either both go up or both go down. The leading coefficient for x to the fourth, that's 1. Since it's positive, then it's just like your parabola. They both go up. It's as easy as that. Okay, number 2, they try to trick you into thinking that 4 is the degree, but it's not. Usually the highest exponent is written first. In this case, it's not. Here it's 5. So I know it's odd. One's going to go up, one's going to go down. The leading coefficient's negative. So this is where you get this right here. You get the upside down normal S curve. So to the left it goes up, to the right it goes down. Number 3, let's see here. Well, the first one is the highest exponent, so it's 3. So it's going to be like the S curve, and its leading coefficient is positive, so it's going to go up left to right. So it goes down to the left, up to the right. This is all we're doing. Okay, number 4, well, we see that 4 is the degree. The leading coefficient's negative, so this is like an upside down parabola. It goes down to the left, down to the right. Very, 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 very simple. Now 5, 6, and 7, you can see these right away. These are written differently than 1, 2, 3, and 4. The reason they're written differently, or the reason why they are different than the first 4, is it's factored out. Now you might look at number 5 and think, oh, this is easy, the degree is 2. But it's not. You would have to multiply this out. Now, again, don't waste your time multiplying this out. You know if you FOIL this, you're going to get x squared. And if you multiply this with x, you're going to get x cubed. So you know right away your degree is 3. Here's a way of doing it. The exponent here is 2. The exponent here on the outside is assumed to be 1. If you add those, you get your degree of 3. So right away I know it's an S shape. All these x's are positive here. So it's going to be positive x cubed, so it's going to go down to the left, up to the right. Okay, to find, I'll put D. I'm going to put D meaning degree. So number 5, the degree was 3. Number 6, the degree, well, I have this 2 and this 2. When you multiply them out, you add the exponents, your degree is 4. So they're both going to go up or go down. And you might say, oh, this is a negative, so it's going to go down. But when you square this negative x, this becomes positive x squared. And this positive x and you square it gives you another positive x squared. It's going to give you a leading coefficient that's positive. So don't let this negative fool you sometimes. If this is raised to an even power, this negative here is going to change to a positive. So this is going to look like the normal parabola. It goes up to the left and up to the right. Okay, number 7, again, it's factored out, so I can't just look and say, oh, well, the degree is 3. It's not 3. I'm going to add these two 3's together. This tells me that 3 plus 3, the degree is 6. So they either both go up or they both go down because the degree is even. Now this is going to be a little bit different from number 6. This negative x, when you cube it, since you take a negative and raise it to an odd power, it stays a negative. So I'll put this here. When you cube that negative x, it becomes negative x cubed. And this positive x, when you cube it, well, it just stays x cubed. So when you multiply these out, it gives you negative x to the 6th. So your leading coefficient you proved right there is negative. So your end behavior is they both go down. All right? So that's the end behavior there. So anything you're doing right now, you're just drawing the little arrows. I don't care about the whole middle part. We're going to worry about that middle part in the next couple of videos. Here we're just kind of getting a little sampling, a little preview of what we're going to do for the last couple videos in 2.2.